Today in the Daily Dose, breakthroughs in antimatter. Before the Big Bang, matter and its opposite, antimatter, existed in equal amounts. Yet after the stars, planets, and galaxies formed as matter-dominant objects in the universe, matter and antimatter had successfully combined to cancel each other out, leaving nothing behind but light. As a result, over the last 100 years or so, antimatter has proven to be fiendishly difficult for scientists to isolate, confounding theoretical physicists as far back as Albert Einstein's 1915 publication of his general theory of relativity, opening up an endless debate regarding the behavior of both matter and antimatter. While matter falls downward under the force of gravity, many physicists have theorized that antimatter may well fall upwards instead, although Einstein himself took the opposite stand, believing that antimatter mirrored the behavior of matter. In his quest to understand the fundamental behaviors of the universe, Aarhus University professor Jeffrey Hangst has spent the last 30 years building his antimatter factory in France, recently succeeding in creating the opposite of the simplest element in the universe, hydrogen, and its neutrally charged antagonist, antihydrogen. By looking at how antihydrogen behaves, Professor Hangst hopes to answer one of the biggest mysteries of why there is no known antimatter left in the universe. Recently published in the peer-reviewed journal Nature, scientists at the Antimatter factory produced antiprotons, the charged opposite of positrons, by colliding particles together in the center's accelerator, arriving via feeder tubes at their antimatter lab, as they call it, somewhere close to the speed of light. In an effort to slow the particles down for proper study, researchers then send the particles around a ring, which draws out their energy, before sending their chosen positrons and antiprotons into a giant magnet, which traps thousands of atoms of antihydrogen. While their initial results confirm Einstein's belief that antimatter falls downward under the force of gravity, their finding opens an intriguing gateway for additional research, specifically to determine if matter and antimatter fall at the same or different rates of speed, making breakthroughs in antimatter a potential game changer in man's understanding of the universe. And there you have it, breakthroughs in antimatter, today on the Daily Dose. If you enjoyed this short educational video, consider giving the filmmakers a YouTube super thanks from as little as $1, so that you too can feed the filmmakers who feed your brain.